Hi guys, it is April 30th. It's Thursday. It's the last day of April, which is crazy to me. I can't believe it's going to be May and we're still not back in the classroom and I miss you guys. I know it's been hard on me, so I know it's been hard on you guys lately. I hope that you're staying positive and doing something for yourself each day and your family because it's just real easy to get stuck in our heads when we're home like this. So just be safe. Remember to reach out. We're all here for you. I do not care if it's not science related, it's not school related. Just make sure you're staying healthy and safe for yourself, okay? That's the number one priority right now, just so you guys know. But let's go ahead and learn something if we're here. So if you can handle it. All right, so we do have an assignment today. I'm going to warn you, this video, I have a feeling it's going to get a little bit longer just because of what we're doing in Amplify today. So it hasn't been that bad lately, especially when I talked to the other science teachers the other day and found out what they're assigning a day versus what I am. But I'm going to keep it still at what I'm doing because I think it's fair to you guys. So we're going to get into 2.4 part 2. I'll get into more details on that. You guys know you're doing your learning log. That's going to be your assignment for tomorrow. So just keep that going. All right, so first thing I want to go over was the warm-up from yesterday. I've started to grade those of them that have been turned in already, and overall, they're really, really good. There's been a couple where I've made some comments. Make sure you go look at what I highlight, because I do highlight something and make a comment there, and sometimes those are even more important than the big comment at the top, just so you guys know. All right, so this was the picture from the warm-up yesterday. Okay, what we know that the sun gives off all of these types of waves of light. So we've learned that. We know that gamma rays and x-rays are really powerful, right? But what we should have learned from this picture is that those two do not hit the Earth's surface. So they get blocked out in the ozone and the atmosphere. And thankfully, because that's the only way we could survive on land, right? But these lights all come through. We get ultraviolet, visible, infrared, microwaves, and radio waves. Okay. What we still do not quite know, it's still unclear why one or more of these types of lights cause skin cancer. So most of you correctly picked out which one here causes skin cancer, and it's the one that has the most energy. And a lot of you talked about how it was the one that damaged the plant, which was great. And you were correct in that one. I'm not going to give away the answer quite yet because there is still some people that don't have it yet. But you did really well. Okay. So we still need to discuss what makes these lights different and why can like a material just absorb one type of light versus the other types, because we know all of these are coming through. They're all hitting the grass. They're all hitting our skin. Why does one cause why does the genetic material take one in and cause damage and the other ones don't? So in order really to understand that, I need to remind you of some concepts from chapter 1. So first of all, and we're going to come back to this again next week, by the way, remember, 3 things can happen to light. It can be reflected. That means bounces back. So this one always weirds students out because what we see is what gets reflected back into our eye. So an apple is not really red. We just see it as red because red light is reflected off that apple. It's absorbing the rest of the colors of the rainbow, which is the rest of the visible light. So we'll come back to that. I know I've given a few lessons at this and hinted at it, but we'll come back. Okay. The other thing that can happen to light is that it transmits. It just goes straight through. So like we see that all the time with like a window, so some clear glass, some air, the light is going through the air, through the window, through things. We know that. Okay. And then what we also know is that light gets absorbed. So light goes in and stays, right? Here were our key concepts from chapter 1. So we know that energy can be tracked by observing changes in the energy caused by matter. We know light carries energy that causes materials to change. When light hits a material, the material can absorb the energy from light. And to put all those together, when a material absorbs energy from light, the energy causes the material to change. So remember, in order to get a change, the material has to absorb the light. And not all change is good or bad. Some change is good, some change doesn't matter, but there is, in order for a change to happen, the light has to be absorbed. It has to go in and stay. Okay, so let's jump in now to lesson. So I'm in 2.4, part 2. Okay. So we are modeling light's effect on genetic material. So the first thing this does so there's 2 pages on here, by the way. We're not going to do anything on page 1, but we are going to follow the directions. Okay. So we have the same picture because we're talking about this today. We're testing it out in our sim. Okay. So we're going to show what happens to genetic material as we expose it to different types of light from the sun. So we're going to use the sim to test the effects of different types of light on the sun on genetic material. Refer to the images above to see the types of light that from the sun that reach Earth's surface. Turn show energy on. So let's click the sim. Okay, remember show energy is up here. And okay, so we're going to drag the genetic material, that's the DNA, to the platform. We're going to test it. This time we're going to use the laser. And then we're going to use the slider to change the laser from, and we're going to look at UV, visible light, infrared, microwave, and radio wave. Okay, so genetic material, laser on. Okay, so what I see right now is right now it's on a green laser. Notice that the green laser is going through, and so is the energy. So the word for that when it passes through, that is transmitted. That means it's passing through, right? It's going through. So let's look and see what happens when I press inspect there. Why is it being weird? Let's try it again. There. Sorry about that. All right, so there's no change. So that makes sense. Light is not being absorbed. There's no change. All right. So that was, if I go back to my directions, that was a visible light, any color. So let's go back and do UV. And we've done this one before, but let's just make sure. So I know that in this case, they have UV over here, but see, so it says ultraviolet. Notice now what's happening to that energy. Those arrows are no longer going through. They're going in and staying. So what does that mean is happening? It's not being transmitted. Is it bouncing back or is it being absorbed? Okay. Well, let's inspect. Now, what do we have? We have a change. It's damaged. Okay. Let's go to infrared. So again, I know you guys don't have the EM spectrum, that's what this is, memorized, but I know the infrared is on the other side of red light, so you just have to kind of drag it and find it. Notice, just like ultraviolet, the energy is going in and staying. Again, what's that word? Let's press inspect. Okay, this time we don't get damage. We get increased kinetic energy. So what the heck does that mean? Because this one is something that I expected us to kind of struggle with a little bit. So what is happening with this infrared? So this is what I just showed you. Does infrared cause a change? Yeah, there was a change, right? It's not damaged. So was it damaged? No, it's not damaged. So when the infrared light hits molecules in our skin, the kinetic energy of those molecules increase and we just feel warmth. So infrared lights are like the lights that they put in like fast food restaurants that where they put the food under to keep the food warm because it's warming. So infrared light can make your skin feel hot, but this feeling is not the same as damage. So it doesn't lead to skin cancer. So infrared does cause a change, but it's not causing cancer. Okay, let's go test the other ones. So we still need microwave and radio. So let's just go ahead and do both of those. So I also know that microwave is just further this way. So there you go, I'm on microwave. Notice what's happening. It's not being absorbed anymore. It's not going in and staying. Instead, it's being transmitted. It's going through. So what is that going to mean for us? Is that going to be a change or no change? And if you guessed no change, you are correct. All right, and last one. Let's change it to radio. It's going to be all the way at the end. And again, what's happening? I'm going to let you look and figure, because you should figure out the trend by now. All right, so we've done that. What we are not going to do is we're not going to do these models. Instead, we're just going to move on to page 2. All right. So we're going to answer, these are the questions that you're going to answer with that sim. So hopefully you try it for yourself. But which types of lights were absorbed by the genetic material? There is more than one that you need to pick here. Okay. Which types of light caused damage to the genetic material? So which types of light cause damage? It could be one, it could be more. I'm not going to give you that answer. Which types of light are not absorbed by the genetic material? It does not go in and stay. And that again is going to be more than one. Okay. Then you need to answer these questions. Can ultraviolet light cause damage that leads to skin cancer? Yes or no. All of these are yes or no. Can visible light cause damage that leads to skin cancer? Okay. So again, that's just going through the sim. It's the same, it's the steps from page 1 without doing this extra little piece here, these models. So you're just following these steps, answering the questions here today. All right. And then again, I will be grading these as I get them so that you try to grade most of them tomorrow if they get turned in early enough in the day, which is tomorrow's Thursday, today's Wednesday, sorry for the confusion. So that you can get your learning log done as quickly as you want to get it done. If I don't get it graded and it's still early enough that you don't think I'm going to bed, then email me. I'll go grade it real quickly for you. All right. Hope you're doing well. And I will, office hours. Office hours are today again from 2:30 to 3:30. So jump on, say hi. I'm not getting enough of you joining, but I do really miss your faces. So please come on to office hours and say hi to me, right? All right. I'm going to put the link for office hours right in these slides. It's not there yet, but it will be once it's posted. Have a great day.